Alright, hi guys. Welcome to this lecture review or exam review. Now, I start doing these review lectures with the P2 class. Um, the purpose of these review video is really to summarize and to highlight some of the key concept of a given topic or given exam. They do not present new material. Okay, it also doesn't mean that the stuff in here are the only thing that is on exams. Okay, so you are always expected to be fully prepared for an exam, but I will highlight some of those most important things that you don't want to miss. Okay, now here is the warning: do not watch this when you're feeling really sleepy. Okay, it is the best non-pharmacological sleeping aid available in the world. I know we learn about a lot of different drugs, but my voice is probably better to put you to sleep than all these drugs. All right, without further talking, let's go into our exam one review. Okay, I promise you this shouldn't be more than 20 minutes, hopefully. All right, so here is the breakdown of my questions for exam one. So a total of 26 multiple choices plus one or two including one or two true or false questions. Okay, 2 points each, right? Regular. So here are the breakdowns. I'll also upload this slide along with my video recording, so you can go along with a printout or something if you want to. Give or take one question per topic. For bipolar, really that is one question. We'll get into it toward the end of the slide. Now, let's break down to the question types. Really, what I'm looking for are some basic questions. Okay, some of those are basic recall of information. Okay, focusing on receptor types, ions, enzymes, associations. Okay, so what I really mean are some of those intro materials. Okay, things like the, let me see if I can write this. Things like the GABA channels. Okay, GABA channels, or glutamate. Okay, glutamate channels. Okay, what are the glutamate channels, and what are the GABA channels? Okay, really the basic principles of pharmacology. So we're talking about, so how would you design a drug, okay, to work at a synapse? Okay, removing the neurotransmitter or retain the transmitter, blocking some enzymes, blocking some neurotransmitters. All right, some of those basic principles that I have all of you do in class. Okay, so those are the basic questions. Some of those, what are the neurotransmitter regular wakes or sleep? Okay, so those are, for just examples of those. Okay, so we have um the sleeping one, the wake one. So really the sleeping one is the GABA. Okay, wake one, we have a couple of those like orexins and histamine and things like that, right? All right, so some of the mechanism of actions for drug or drug class covered in class. All right, definitely benzos. Okay, benzos and barbiturates. Okay, things are like such as the durations versus frequencies, and also where are they binding. Okay, not that you need to pinpoint the exact location on a graph, just know that they're binding to a site that is different than their than GABA binding. Okay, some of the other sleeping aid, non-benzo sleeping aid pharmacologies. Okay, what are they? Okay, what are the basic mechanism of actions for those? Now, get clear in your head when a drug is a agonist versus an antagonist. Okay, so we have some of those are antagonists, such as all those antipsychotic drugs. Okay, all right, so here are just some of the example questions. Those are very basic. I'm not going to go over these questions. You can look up on your slides very easily. That's not anything in particular challenging. Okay, so you've seen the quiz, or you will see the quiz on Tuesday, depending on when I upload this video. But anyway, you know some of those basic things that I'm looking for. All right, so there are a lot of medicinal chemistry informations that are covered in class, particularly in the antipsychotic material. So, here are some of the general thing that I want you to be able to understand. Okay, if I give you a couple chemical structures, okay, be able to identify the drug class that it belongs to. So, for example, can you recognize the phenothiazine? Okay, phenothiazines. Okay, what are they? Okay, what do they look like? Okay, right, what do they look like? TCA, if I give you a couple compound, can you recognize TCA from a group of compound? All right, so know the general structures. Okay, and also same for barbiturate, not barbiturate, I mean benzos. Okay, we went over structures for benzos. Okay, and can you recognize them? All right, and also about these structural activity relationship, SAR. So those that are emphasized in class, you particularly need to pay attention. Okay, things like phenothiazines. Okay, the sulfur bridge. There is that electron withdrawing group on one of the ring that tilted the plane, and then how it matches it cis versus trans and all these. Okay, and so that's so same for benzo. Okay, some of the structural activity relationship that we emphasize, you expect to know those, and how these things change its activity. Okay, is it increasing, decreasing? So not only to memorize these statements, you also expect to understand those statements and be able to tell these information from looking at the structure. Now, I will never ask you what this drug versus what the structure is. Okay, what this drug corresponding to what structure, what name of it. Okay, only the drug class. Okay, recognize the drug class. Okay. All right, so here are some of those, in-depth particular guidance on some of those benzo. Okay, what is required at R7s. Okay, like things like some electron withdrawing group, some of the general theme that we've seen. Okay, and then something about the half-life. Okay, what structural differences affect its half-life? We talk about it if it has a OH group there already, so it means it has been through a step of metabolism. So there's only one metabolism, and then one more step, and you go to eliminate it. Okay, so those concepts you need to be able to grasp that, and be able to tell from a structure. Again, here are some of the more simple questions. Okay, in general, here are what I'm saying, that matching some of those principles of those structures. All right, pharmacologies. Okay, so get clear in your head with the pharmacology regarding antipsychotics. Okay, those are the most difficult one in my opinion. Okay, I'm sorry. In particular, with some of the atypical or typical psychotics. Now, so if I am giving you a atypical antipsychotics, things like Abilify or Pipazole. So that is the major one, right? We spend a significant amount of time on that one. So know what receptors they are binding. Okay, 5-HT1A versus 2A. Okay, really those last couple slides in that first package are very, very important. Okay, and know that the pharmacology, is it agonist, antagonist? Get clear in your head. Okay, neural pathways, particularly for atypical antipsychotics. Okay, it work on all three pathways. Okay, the nigrostriatal, the mesocortical, mesolimbic. Know what they do in individual pathway, and what are the overall effect of the dopamine. Okay, what pathway we want more dopamine, what pathway we don't want dopamine. Okay, in terms of the atypical antipsychotic and how it works on schizophrenia. Okay, these are very, 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 very important concepts that you need to grasp. Okay, so all right, looking at this sample questions, I don't know why it says no audio here. All right, so here are some of the sample questions. Okay, depicting some of the antipsychotic. So here we're talking about SDA, serotonin dopamine antagonist, and here is the situation where serotonin is being released from the serotonin releasing neuron. Normally it has inhibition actions. Okay, bind to dopamine receptors, and then on this it binds to serotonin receptor that is on this dopamine neuron, and it makes it decrease the release of dopamine. Right, so you need to get clear with what are these receptors are, okay? And here as well, the blue receptor, are they D1 or D2? What pathway are we talking about? Okay, nigrostriatal, and mesocortical, right? Okay, so those are some of those important things that you need to get clear in your head. And what are the overall effects on dopamine level? You want more or less if you have the drug. All right, so in terms of the bipolar, really that would be one question. I'm very open with that. All right, so it would be on something about lithium. Okay, very, very basic big headings of these lithium. Okay, what are the general mechanism of action? So not go into great detail. Okay, just know the general. Sorry. Now, in terms of seizures, okay, we went over in 30 minutes or less time. So I told you guys, focus on some of the table there. So table is really a good starting point, okay, in order to start to get things a little bit organized in your head in terms of what their target. Okay, general mechanism is what I'm focusing on, really, unless that I pointed out. So the main thing, okay, the main detail thing that I want you to know is about it's the sodium channel blockers. Okay, I acted out in the video I posted earlier on. So I really want you to know how sodium channel blockers work, okay? What they bind to those inactivated gate, right? Inactivation gate, right? So it keeps it at the closed positions, and they, so that it doesn't open again. Like, so, and note some of the details on phenytoin, okay? This one of the classical drug for seizures, and also a sodium channel blockers. Like, so, there are a lot of sodium channel blockers, okay? So that graph toward the end of that package or that slide can help, or the table can definitely help. Another thing I want to point out is all those GABA analogs, okay? Those GABA analogs, they are designed to look like GABA, okay? But, big but, they don't act like a GABA, right? They don't act like a GABA. I cannot emphasize this enough, okay? So be sure, okay, go through the table. Be sure, to know what each of those GABA analog binds. Okay, they are not binding to GABA receptor just like a GABA. Okay, I say that again. All right, don't miss that type of a concept. Okay, so you don't need to know any structures on this anti-seizure or anti-epileptic topics. Okay, like I said, I read it there. Table figures at the end would be very, very helpful to study. Now, coming to the last topic, okay, it's about ADHD and stimulants. Okay, not many questions in that. And in terms of drugs, really, I'm focusing on the stimulant drugs. Okay, I cannot ask too many questions. So we're talking about amphetamine and methylphenidate. Okay, know the pharmacology, know the pharmacodynamics, right? Low dose and high dose effects. Okay, that's the important things about that. That topics. Right, in terms of the first bullet point, I almost missed that. So what are the biology or pathophysiology underlying with this this disease, ADHD? What kind of neurotransmitters are insufficient? All right, too much, too little of what? Okay, tonic versus stimulations. Okay, so all these things are important, okay, in terms of ADHD. Right, so that's all. Okay, that's all. I told you it's not gonna be a lot. All right, so good luck studying, and email me if you have questions.